All right, I thought this was a good question that stumped me the first time around, so needed to set the record straight a bit. It says find the maximum domain of the function f of x equals the square root of 1 minus x on x plus 1. I suppose the first thing I thought to do, which was wrong, was not wrong, but it just didn't help me find the solution, was to say to myself, all right, in order to find the maximal domain, it's under the square root, so this whole thing has to be greater than 0. So a logical first step might be to set this thing to be greater than 0 and then try and solve it. If you try and solve this, we know that when we solve inequalities, we do everything the same as equations. But if we multiply or divide both sides by a negative, we swap the sign. So we might get something like this, 1 minus x on x plus 1. We want all of that to be greater than 0. Take away 1 from both sides gives us this. And then divide both sides by -1 just to make it all positive. But then we flip the sign, so we get x on x plus 1 being less than 1. All right, multiply x plus 1 to both sides, and then we get that x plus 1 is greater than x. Well, that's obvious, isn't it? Some number plus 1 is always going to be greater than that number, and then even if you go further, you can take x away from both sides, and you get that 1 is greater than 0, so there's no real surprises there. So you can see that this method sort of doesn't work first time around. So what you need to know to do is that you need to do what's called re-expressing this fraction. Okay, and let me show you what that looks like. I'll put a link below to explain what re-expression is, but basically it's a quicker way of doing long division. But I think if I just show you, it should make some sense. So basically, if we just zone in on this part here, we don't like the fact that we've got an x in the numerator and the denominator. We want to do away with that. So we might say to ourselves, all right, let's re-express x on x plus 1. And this is the process of re-expression. Basically, you set up the numerator on the left-hand side, the denominator is sort of this factor on the right-hand side, and then you ask yourself, all right, what needs to go in this box and this box? And this should make sense. X is equal to 1 multiplied by x plus 1 minus 1, sort of adjusting it. Again, I'll put a link below to explain how re-expression works, but I think that should seem like a logical step as something we can do without breaking any rules, right? Okay, and then, so you're looking at this right-hand side now, we can divide everything by x plus 1. So on the left-hand side, we get x on x plus 1, but now we've re-expressed it. We're going to be left with 1 minus, okay, this 1 here is going to be divided by x plus 1 because we've divided the right-hand side by x plus 1. And then we now know that x on x plus 1 is the same thing as 1 minus 1 on x plus 1. So we're going to rewrite f of x, which is going to rewrite this part with our re-expressed form. So we get f of x equals 1 minus 1 on x plus 1. Okay, very important you have the brackets there, otherwise you'll make a mistake. 1 minus 1 is 0. 1 take away all of this business is positive this. We're taking away a negative version of this, so that's all positive. So we get that f of x is the square root of 1 on x plus 1, which is the same rule as this. Same. But this is much neater. And now we say to ourselves, okay, well, where is this? What's the maximal domain of this function? It's a lot easier to work out. We know that the maximal domain, we know that because it's under the square root, it has to be greater than 0. And this fraction is only greater than 0 if the denominator is greater than 0. Okay, if the denominator is negative, then the whole thing's negative. And it can't equal 0, because if it equals 0, we've got a problem, because then we're dividing by 0. So we can see that x plus 1 has to be greater than 0 for this thing to be positive. So x is greater than -1. And sure enough, if you haven't already seen, that's this graph here. That is this blue line is the graph of f of x. And this dashed line, you can clearly see it's got an asymptote at -1. So it gets infinitely close to -1, but never touches it. So that's how you do that. Interesting maximal domain question. I thought it was a neat one, and it stumped me the first time I saw it. So let me know what you think. Give us a thumbs up if you found that useful at all, and good luck with your studies. I'll see you soon.